Alright, welcome. In this video, I'm going to be working the Unit 0 review for AP Pre-Cal, which is really just a bunch of problems from the quizzes scrambled up and put in a different order. Because what we are saying in our AP Pre-Cal course, the quizzes are the review. And so moving forward, we'll have other things available for you to practice on. I think we'll use the personal progress checks in AP Classroom. But really, if you're wanting to look and see, like, what do I need to know for the test, you need to go back and look at the quizzes. That's going to be the thing all year. Okay, so given c is a positive constant, which of these graphs could be the equation of m of x equals x minus c squared? Okay, well, since c is positive, and we're subtracting, can't even see that, subtracting c on the inside, that's going to move the graph of y equals regular x squared right c units. But otherwise it would be the same as like y equals x squared, and so that's going to be answer choice B. Now we're going to have f of x equals 4 minus 2 times 5 minus x. We might find f of 0, and so that's just what we would get when we plugged in 0 wherever we saw x in the formula for f. And then we'd say that's 4 minus 2 times 5, and 4 minus 10 is negative 6. If we're going to solve the equation f of x equals 0, we can just copy in f of x. That's 4 minus 2 of 5 minus x, and that's going to equal 0. And so I've got this 4 added on the outside. Maybe I'll subtract it from both sides, and I'd have negative 2 of 5 minus x equaling negative 4. Then I could divide by the negative 2. Just be left with 5 minus x, and negative 4 divided by negative 2 would be positive 2. And then maybe I'll subtract 5 from both sides and divide by negative 1 and see that x is going to equal 3. And you could go and you could check that, by saying, okay, what is 4 minus 2 times 2? That is, okay, that's 0. Okay, f of x equals 0 when I plug in x equals 3. That works. Find the value of x where f of x equals negative 6. Okay, so I'm just going to do the exact same thing. 4 minus 2 times 5 minus x is equal to negative 6. And then zoom in on that. Subtract 4 from both sides. Same exact steps I just went through. And divide by negative 2. Okay, so it'll be positive 5. Oh, yeah, we just saw that f of 0 equaled negative 6, so it would not be surprising if we were solving the equation f of x equals negative 6, we would get negative x equals 0, therefore x equals 0. Yeah, okay, that's just, I think, what we saw right above that. Yeah, f of 0 equals negative 6, so if we're looking to solve the equation f of x equals negative 6, it should return us at least x equals 0. Okay, but since f's a linear function, it's only going to return us that. Okay, so 4 minus 2 times 5 minus x. So 4 minus 2 times 5 minus negative 6. 5 minus negative 6 is going to be 11. So 4 minus 2 times 11, that's 4 minus 22, and that's negative 18. All right, next we've got the graph of w of x, and it's got kind of 3 different curve parts to it, and we're going to sketch the graph of each transformation of w down here. Okay, so g is w of x plus 2. So I think first underneath I'm going to write like what the transform is. And if I'm replacing x with x plus 2, that's going to be shifting the graph of w left 2 units. All right, so I guess what I'm going to do is I'm going to just, let me think about this. The best way for me to do it would be, maybe say the 2 outside parts I'm going to draw in red, and the middle part I'll draw in black. Okay, so, all right, so if I'm shifting left by 2, the far left part will start at negative 2 and it'll go up like that. No, I don't think this has to be the best drawing ever. Okay, then it goes up like by 1 and over 2. Okay, and that'll have to do. And then from there it goes like kind of up 2, I think, and over to the side. And I think that'll be great. Left 2 units. All right. for 1/2 of w of x, we could say this is, you could say it's a vertical dilation by a factor of 1/2. You could say it's a vertical compression by a factor of 1/2, and vertical stretch by a factor of 1/2. I think I'm going to use the dilation terminology because that seems like what they are leaning towards on the College Board stuff that I've seen. So if that's the language they're going to use on the AP exam, that's the language I want to use in the class. So vertical dilation by a factor of 1/2. So over here, where I went up 2, I'll now be going up 1 instead. So, all right. Otherwise, the actual placement of the graph stays the same. So yeah, instead of going up to 2, I'm going to go up to 1 with that left arm. And then the middle lump is going to only go up to 1/2, but it's still going to reach over twice because I'm just vertically stretching by 1/2. And maybe that's just only halfway up to 1. It's definitely below 1. And then it's going to go up and over, and it looks like it went up to 2, so now it will just go up to 1. And that'll be h of x, which is 1/2 of w of x. Okay, all the y coordinates got multiplied by 1/2, so they were vertically compressed. All right, negative w of x minus 1. This has got two things going on. First, we've got the negativity, that's the nearest to w, and so that's going to be a vertical reflection, or like flipped upside down. So let's say reflect across the x-axis. And then we could also, and then the negative 1, we're going to say it's going to shift down by 1. All right, so the left arm is going to, now it's going to come down underneath the x-axis, but then it's also going to start from 1 unit down. So I think it's going to start over here, and it went up 2, so it should go down 2. Maybe I'll just make that 3, and something about like that. And then we had this lump in the middle, and so it's upside down and got moved down by 1. So it went up to positive 1, so it would go down to negative 1, but then got shifted again, so it should probably go down to negative 2. Yeah, okay, and it still went over by 2. And then the other thing looks kind of the same, but it's a little steeper at first and flatter after. I don't know. That's as good as I've got. Okay, it's upside down and it got shifted down by 1. That's what's important. All right, okay, there was only 3 of those. That's good. So let f of x equal 2x times x plus 3. Find all x intercepts. Okay, we're talking about, x intercepts. That's where we're looking for, places where y is equal to 0. Or f of x equals 0. So we'll say 0 equals 2x multiplied by x plus 3. And now we can apply the zero product property and say when that is factored, either 2x is equal to 0 or x plus 3 is equal to 0. And that would give me x equals 0 or x equaling negative 3. Okay, find all y-intercepts. Y-intercept, that's going to be a place where x is equal to 0. Now, if f is going to be a function, then, it's not going to be able to have more than one place where x is equal to 0. So we just say, okay, f of 0 is equal to 2 times 0 times 0 plus 3, and that's going to equal 0. Okay, so that would be like, y equals 0. And, we'd already seen that x equals 0 was an x-intercept, so that would mean that y equals 0 is going to be a y-intercept as well. I'll let you think about why that's true. Okay, f of negative 4, okay, that f of negative 4 is going to be, just replace x with negative 4. So negative 4 plus 3. So we've got 2 times negative 4 times negative 1, negative 8 times negative 1, that's going to be positive 8. And then find the value of x that gives you f of x equals negative 4. We can do that. So 2x times x plus 3 equals negative 4. Okay, now we're going to need to distribute this out so that we can refactor, because we're going to have to set it equal to 0, because we're going to have more than one power of x. So I've got 2x squared plus 6x equaling negative 4. Maybe I should zoom in on this a little bit. Now I'm going to need to set it to 0. And yeah, I'm gonna look for a greatest common factor. I see that all these numbers are even, so I can factor out a 2. A second. Do something wrong here. Yeah, it definitely did, and added 4 to both sides, and wrote as a -4. Okay, so that would be +2 there. Yeah, that is something I can factor. I was like, I don't remember this happening on the quadratic formula quiz, so all right, so yeah, now I can say what are two numbers that multiply to 2 and add to 3? That would be 2 and 1, x plus 2 times x plus 1, that's going to equal 0. And so that would happen either if 2 was 0, which it wouldn't, or if x was equal to -2 from that factor right there, or possibly if x was equal to -1 from that last factor there. And so I've got -2 and -1 being my solutions to that equation. Next, we've got f of x equaling x squared minus 6x. Then it's going to ask us to start by finding the zeros of f. And so, well, I guess what I would really need there, if I want the zeros, would be to set the function equal to 0. So 0 is going to equal x squared minus 6x, and then I'm going to factor this thing. Because I see I can, and also because I've got x squared and x, and it's set equal to 0, so that'll be the way to go. Greatest common factor is x. I'm left with an x and a minus 6. And then I'm going to take each of the factors and individually set them equal to 0 because it's a product that's equaling 0, so that can only happen if one of them is 0. So either x is 0 or x minus 6 is 0. And I've got x equals 6 and x equals 0. And so those would be my two zeros. Okay, the value of f of -2 will equal, f of x is x squared minus 6x. So if I plug in -2, I'll have 4 plus 12 is 16. Okay. Solving the equation f of x equals -9, I go and I grab f of x, that's x squared minus 6x. And I say that's equal to -9. And then I'm going to need to set this equal to 0, just like the other one. And I will, I think, I'm going to look for two numbers that multiply to 9 and add a -6, and that would be -3 and -3. At this point, you see either x is going to need to equal 3 from this perspective, or it's going to need to equal 3 from that perspective, but either way, if we want this equation to be true, we need x equal to 3, so that's the only solution to our equation. Okay, we will solve the equation f of x equals -5. Okay, so again, x squared minus 6x, that's f, and that's going to equal -5. I'm going to set this thing to 0. Hope to factor. But knowing what we know now, if it can't factor, we'll just use a quadratic formula, and maybe the solutions come back complex, and we're not going to be scared of that either, and it's going to be all right. Okay, but this one, I'm thinking of two numbers that multiply to 5 and add to -6. That'd be -5 and -1. So I factor this into x minus 5 times x minus 1. And I say, okay, either x minus 5 needs to equal 0, and that would be where x is equal to 5, or maybe x minus 1 needs to equal 0, and that would be where x is 1. Now, next, we've got one that's kind of already factored for us, but we're talking about the vertex. So if you've got a quadratic equation that's already factored for you, I mean, you can distribute it out and figure out what is -b over 2a to find the x coordinate, and then plug that into the original formula for h to get the y coordinate. But you could also just figure out what the zeros are of the X intercepts on the graph of h and average those, because we know the vertex is going to be halfway in between the X intercepts on a parabola because of its relative symmetry. All right, so that's what I'm going to do. So I'm going to start with the idea of the zeros of h. And that's going to be where x is equal to 3 from here, or where x is equal to -2. then I'm going to say, all right, well, the x coordinate of the vertex the average of 3 and negative 2. Okay, so half of 3 minus 2 is equal to half of 1, that's a half. And then the y coordinate is what I get when I plug in x equals 1/2 into h. And so I'm going to say h of 1/2 equals 2. And I see some fraction arithmetic coming up, so I'm going to write that as 2 over 1 multiplied by x minus 3. A half minus 3 is negative 2.5. That's a negative 5 over 2. And x plus 2, a half plus 2, that's positive 2.5. That's also going to be 5 halves. You may have noticed that it's kind of multiplying the same thing there, and that's not a coincidence, but that's not really what we're talking about here today. And then I should probably do a little bit of canceling. Although what you could do is you could just say 2 times negative 5 is negative 10 times 5 is negative 50 divided by 4. And then simplify that way if you're prone to simplification errors. But I will point out, if I've got a 2 here, I can cancel out a 2 there. Can't cancel out both of them, right? I would need 2 2's up top to cancel both 2's on bottom. But I can do that and say, all right, this is negative 25 over 2. As a result, I can just say, that would have been a good enough answer for me. But, if you had to write the coordinates, it would be like 1/2 and negative 25 over 2. Now we're interested in solving the equation h of x equals negative 11. All right, so I'm going to copy in h of x, 2 times x minus 3 times x plus 2. That's going to be equal to negative 11. All right, so I'm going to need to distribute and then reset to 0, hopefully refactor, but if not, I can use the quadratic formula, it'll be no big deal. And solve that way. So x minus 3 times x plus 2 should be an x squared, negative 3x plus 2x, and negative 3 times 2. Okay, so I'll have 2x squared minus 2x minus 12 equaling negative 11. I'll add the 11 to both sides. Minus 2x minus 1 equals 0. And I'm going to look at this and see if I can factor, because it looks like maybe it could be. Can I think of two numbers that multiply to negative 2 for multiplying the leading coefficient in the constant term, while adding to the middle term, negative 2, and I don't think I can. Yeah, it's going to be 2 and negative 1 or negative 1 and positive 2. Neither of those are going to add to negative 2. All right, so it looked factorable to me, but it was not. So then we're going to use the quadratic formula. And I think this is the first time in this video that I've had to use the quadratic formula, so I might as well just remind you of it. We need to know it. It's x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Or maybe if you learned it differently, like maybe negative b over 2a plus or minus that same square root over 2a, but this is like harder to remember, in my opinion. Okay, but it's all the same, right? Okay, I'm going to need to get rid of a lot of this in order to actually do my work in here, so get rid of that one, because the one on the left is the one I'm going to use. They're the same, so it doesn't really matter. So x equals negative b would be negative of negative 2 right there in the middle. Plus or minus the square root of b squared would be negative 2 squared. That's positive 4 minus 4 times a times c. All over 2a would be 2 times the leading coefficient. And I need a little more space. Go back up here. So this is x equals 2 plus or minus the square root of 4 plus 8 is 12 all over 4. All right, and you can't see that at all. Pardon me, I was blocking it. And then this square root of 12 right here, this is something we're going to need to be able to simplify. So maybe we'll go over here off to the side, and say the square root of 12 is the square root of 4 times 3, which I can write as the square root of 4 times the square root of 3. So that's 2 square root of 3. And so if I've got 2 plus or minus 2 square root of 3 all divided by 4, that's 2 over 4, that's a half, plus or minus 2/4, that's another half of the square root of 3. Or you could call that root 3 over 2, however you like. Okay, that's how we're going to solve that one and simplify our answer. And then, okay, if f of x is 3/4 of x plus k, where k is an unknown that can be found given f of 8 equals 4. What's f of negative 4? Okay, we've done this problem many times. Okay, so what was it? F of 8 equals 4. So I'm going to use that information to find the value of k. So f of 8 equals 4. So I plug in, 4 for f and 8 for x. And 3/4 of 8, you could do 3 times 8 is 24 over 4, or you could do 8 divided by 4 is 2, and then the 2 times 3, either way you get 6. So 4 is 6 plus k, and that feels like k equaling negative 2 to me. All right, and then step 2 will be find what they asked for, f of negative 4. So we know that f of x is 3/4 of x plus this k number, which we found out was negative 2. So that means f of negative 4 is going to be 3/4 of negative 2. No. Well, I was thinking, I see why I would think that. I was getting ahead of myself. 3/4 of x, which is negative 4 minus 2 more. Okay, so 3/4 of negative 4 would be negative 3 minus 2 more, and that's going to equal negative 5. That's what they were looking for. Okay. We have now g of x equaling x squared plus 4x minus 1. Find the location of the vertex on the graph of g. And if it's in standard form, I recommend just using the formula. On the vertex, at least the x coordinate of the vertex on the graph of a parabola is x equals negative b over 2a. And so we can use that. I will say x equals negative b over 2a. So negative 4 over 2 is negative 2. And then y will equal g of negative 2, which will be negative 2 squared plus 4 times negative 2 minus the 1. And so I've got 4 minus 8 is negative 4, minus 1 is negative 5. So my vertex coordinates would be negative 2 and negative 5. As for the locations of the zeros of g, I'm just going to set g of x equals to 0. So 0 equals x squared plus 4x minus 1. Okay, so this is not going to factor. I can't think of two numbers that multiply to negative 1 while adding to 4, so I'm going to use the quadratic formula. And x will equal negative b plus or minus the square root of b squared minus 4ac to a. And so what's going to happen is, I guess that's going to be a square root of 20 right there. And yeah, 16 plus 4 is 20, so square root of 20 is square root of 4 times square root of 5. And that would be 2 root 5. So I've got negative 4 plus or minus 2 root 5, all divided by 2, and I need to simplify, so I've got negative 4 over 2 is negative 2. Plus or minus 2 over 2 is 1 square root of 5. All right, now we're going to transform the graph of y equals x squared. Okay, so g of x is going to equal x minus 2 squared. So that's going to be right by 2 units. We did something like, we did a multiple choice question that was like this one. All right, so if we have 2 over here, and that's going to be the direction right to the right. It's a pretty decent parabola. All right, and then h of x equals x squared minus 2 would be a shift down 2 units. So I'm going to just mark off negative 2 here, but otherwise I'd have the same usual graph of y equals x squared. Not bad. J of x equals 3x squared would take it and make the y-coordinates 3 times as much, so it'll make the graph 3 times as tall. I might characterize that as making it skinnier, which is not untrue, but really the effect of the multiplying the 3 on the outside makes it 3 times as tall. You could also say it's a horizontal compression, but I'm not going to get into the factor. That's not what we're talking about today. Regardless, it's going to make it taller. Okay, so vertical stretch, vertical dilation by a factor of 3. Okay, so it's just growing faster. Here we've got a negative x plus 3 squared plus 4. So there's 2 different things going on here. So I've got the negative, which is going to turn the parabola upside down, right? It's going to be a reflection across the x-axis. So I might just write that in here. Oh, whoops, wrong pen. Across the x-axis. And then we've got the x plus 3 squared and then the plus 4. So that'll be a shift left 3 and up 4. But if we do the reflection across first, then we won't have to worry about do I do it before or after. We know it's going to be upside down, so just make that happen first, then we'll shift. All right, so upside down, then left, then up. Okay, so I should probably block off what I think is negative 3, 4. And then I'll just have a standard y equals negative x squared. I think that's accurate. I do think the y-intercept is supposed to be negative on that thing. That was not a very good parabola, but I'm just going to move on. Okay, given a rectangle with length x minus 6 squared. Width 2. If the perimeter is 22, what are the possible values of x? Okay, so I'm going to add this stuff together. 2 plus 2 plus x minus 6 squared plus another of x minus 6 squared. That's going to equal 22. Hopefully you've done this type of problem enough times, between the notes and the homework and the quiz. I think you should have done it 4 times. So hopefully you've seen the pattern here and you'll be ready for it when you actually do it on the test. 4 plus 2 of these x minus 6 square quantities is going to equal 22, and then I'm just going to solve pretty directly. I'm going to subtract 4 from both sides. Divide by 2. And take the square root of both sides, which will bring in a plus minus. So I'll have x minus 6 equaling plus or minus the square root of 9. And then x equaling 6 plus or minus 3, which is going to be x equals 3 or possibly x equals 9. A lot of room to work that one. Now we can solve the equation and show the work that leads to our answer. Okay, these are from the first quiz, right? But it's still pretty straightforward, and we're just directly solving it, everything. Okay, so what we're going to do is do the same thing on both sides. Well, but now, no, this one's going to have a complex number, so this was not from the first day. I got tricked. So it won't be too bad. Subtract 25 from both sides. Take the square root of both sides. And that's going to incur a plus or minus. Square root of negative 25 is over here. We need to simplify that, right? So square root of 25, negative 25 is the square root of 25 times the square root of negative 1, because I know the square root of 25 is 5. And the square root of negative 1, that's I. So I'm going to go over here and I'm going to say, okay, x equals plus or minus 5 times I after that simplification. Over here, same story. We're just going to deal with the plus 3 at the very end because it's inside the parentheses. So we're going to subtract 4. We'd have x plus 3 squared equaling negative 4. We would take the square root of both sides. Square root of negative 4, that's the square root of 4 times the square root of negative 1 is going to be 2 times I. And then I'll say, okay, x plus 3 equals plus or minus 2i. And then I can subtract 3 from both sides and say x equals negative 3 plus or minus 2i. Didn't realize you could see that. Okay, now here's one with a fraction exponent we're going to have to solve, but really the principle is going to be just the same. We're going to isolate the power of x and then take both sides of the equation to the appropriate power. Remember something if necessary, but obtain our solutions that way. So first I've got on the outside of these parentheses a multiplication by negative 2, so I should probably divide by negative 2 first. And so I'd say this 1 minus x to the 3 halves is going to equal negative 7. And then I'm going to subtract 1 from both sides, so I'd have negative x to the 3 halves equaling negative 8. Would get rid of the negatives for sure. So I'd have x to the positive 3 halves equaling positive 8. And then I need to do the same thing to both sides. I need to take both sides to an appropriate power. So I'm going to take both sides to the 2/3 power. These two things are equal, then their 2/3 powers should be equal as well. And 8 to the 2/3. All right, x to the 3 halves to the 2/3, we multiply the exponents, we get x to the first power. And then we're going to have to take 8 to the 2/3 power. Remember, I'm going to always recommend dealing with the denominator first. That's going to be the cube root of 8 squared. Maybe you can do the cube root of 64. Yeah, you very well may be able to. But, something like 16 to the 3 halves, that's not going to go so well for you, right? And especially not 64 to the 3 halves. Okay, I don't even know that I don't know what 8 to the 3rd is, but maybe I can figure it out a little bit easier than I could figure out what the square root, or the square root of 64 cubed is. Nobody knows that. Or at least nobody I know. All right, so I'm going to say cube root of 8 is 2 squared. That's going to be 4. X equals 4 is my solution. Now, the question that comes up on this one sometimes is, do I need a plus or minus? And on this one, I'm thinking no, because the plus or minus comes when you take the square root of both sides of an equation, or really like the even root of both sides of an equation. But over here, I took the cube root of both sides of that equation in blue, so I'm not seeing it. I'm not seeing the need for a plus minus. In fact, if we had x equals negative 4, when we went back to the original statement of the equation, if we threw in a negative 4 right there, we'd be taking the square root of negative 4, and we'd be getting some kind of imaginary number, and that would not be able to produce a 14 on the other side, so that would be not valid. All right, so I think that's all I've got to say about that one. All right, here's the next ones. And I know that these are some that are at times troubling for us, so I want to make sure that we're good on these. So I might actually do an extra one on this one because it says vertical shift down 5. I might also do a horizontal shift right by 5 just to show you how that would work, because I don't see that gonna come up, as far as actually working out to a standard form answer on this problem set. But if you need more of this, you should go back to the practice problems we did before the quiz on that, because those are definitely, we think we did a bunch of those, and that would be good practice as well. All right, so if I want a new equation for f of x, if it undergoes a vertical shift down 5, okay, well, I'm just going to take f of x and replace it with f of x minus 5. Okay, so the new one would be, I don't really know what to call it, they didn't give a name for it, so I'll just say x squared plus 2x plus 3, that was f of x minus 5. Illustration what I'm talking about, that's what I mean. Okay, so that's going to be x squared plus 2x minus 2 when I combine the 3 and the negative 5, that's it. Okay, I think now I'm going to go and, switch this up to, and now maybe I'll just do the next one, and then I'll just make up 2 others, and you can try them on your own if you're interested, or you can watch me do them, or you can just skip ahead if you're not. But I don't think we're picking this up for a grade, so I think the only reason you'd be watching this is because you were interested and you just want to do better on the test. So I just have a couple extra. So vertical dilation of 3 would be starting with f of x and then multiplying all the output values, the y values, by 3. So that would be 3 times f of x. So really what I want is 3 times x squared plus 2x plus 3, right? It's 3 times f of x, where that's f. So I'm going to say that's going to equal 3x squared plus 6x plus 9. Okay, yeah, let me clear all this out and get a slightly different problem. All right, yeah, so for the same function, what if I shifted right 5 units, or what if I reflected across the x-axis? I feel like those were kind of missing there. So as far as shifting f right 5 units, that's where we would take x in this situation and replace it with x minus 5 in parentheses. But we would need to simplify our answer. So I'd say g of x equals f of x minus 5. And I know we haven't talked about composition of functions this year, but I know that the students in my Algebra 2 class last year were really good at composition of functions, oddly enough. Like, that was one thing we were very good at. I'm not sure where that skill came from, but it was something we had success with, so I'm going to try to build on that. X minus 5 squared plus 2 times x minus 5 plus 3. And then we're going to have to distribute this out and simplify our answer. So we're going to have x minus 5 squared would be x squared minus a 5x minus another 5x plus 25, plus distributing the 2 over the x and the negative 5, and then plus 3. And so I'd have x squared, in terms of total number of x's, I've got negative 10 plus 2 would be negative 8. Then 25 and 3 is 28, minus 10 is 18. Okay, so that's how I'm going to simplify that one. And then if h is formed by reflecting f across the x-axis, that would just be taking all the y-coordinates, multiplying them by negative 1. So that would be negative f of x. So what I'm saying is h of x equals negative of f of x, which is going to be the negative of x squared plus 2x plus 3, which we need to know is equal to negative x squared minus 2x minus 3. The negative would go across all 3 of those. And so that was just the extra couple of examples I needed to show you, just to make you feel like you were the most prepared for the test, right? We still got a number of examples to go, so let's just keep moving. So for f of x equaling 12x to the negative 1, I think I should probably just right now point out that that's this 12x to the negative 1 piece, that's equal to 12 times 1 over x. That's what x to the negative 1 is. And we could write that as 12 over x. And if that's easier for you to work with, then that's exactly what you should do. But, for now, I'll just say, all right, f of negative 3 is equal to 12 times negative 3 to the negative first power. And that's 12 times 1 over negative 3. And 12 divided by negative 3 is negative 4. See how it is 12 divided by that negative 3. Okay. Or you can just use the 12 over x formula if that's how you prefer, but I'm going to try to reason with the negative exponents as much as possible so that they become second nature. Okay, so f of x equals positive 18. So f of x is 12x to the negative 1 equaling 18. Okay, divide both sides by 12. Divided by 12, those are both divisible by 6, so that's 3 over 2. And then, really what I need to do is take both sides to the negative first power, so x to the negative 1 to the negative 1, that's just x, and 3 halves to the negative 1 is 2/3. Okay. But if you had started from 12 over x equals 18, you could have multiplied both sides by x divided by 18 and said that's 2/3 that way. However you want, right? Whatever you think would be your first instinct is what I'm going to recommend you go with. 34 is asking for us to solve our equation and show the work that leads to our answer. All right, so x plus 3 squared minus 2x equals 14. I'm going to square out the x plus 3 because I don't see any clever way of factoring. If you do, go for it. But it doesn't exist on this one. But sometimes there are algebra tricks that I might not see, that we might not see when we're putting together the question. But provided that your answer is correct and mathematically justified, I really don't care how you arrive there. So x squared plus 6x plus 9 minus 2x equals 14. I'm going to say x squared positive 6x minus 2x would be positive 4x. I'll deal with the numbers. Next step, subtract 14 from both sides. That would be something wrong here. 9 minus 14. Oh, yeah, okay. I was thinking it was going to be 7. I don't know why I would think that. That would be negative 5. Okay, yeah, this is factorable. I'm looking for x plus 5 times x minus 1. Positive 4x minus 5, yeah. And so either x plus 5 is going to equal 0, or x minus 1 is going to equal 0. All right. Over here, I've got, again, the same idea. I'm going to need to distribute this out. X squared plus, or negative x. Inside would be 6x, and 6 times negative 1 is negative 6. Okay. Combine the negative 6, or the negative x with the 6x, and have positive 5x, and minus 6 equals negative 12. Add the 12 to both sides. I see where this is going. So 5x plus 6. Negative 6, positive 12 leaves positive 6, and that's going to equal 0. Okay, I'm looking for two numbers that multiply to 6 and add to 5, and you want to be careful with 5 and the 6, because there's 3 and 2 and 6 and 1, and kind of both combined. So you have to be careful about the signs. So if it's positive and positive, it should be positive 3, positive 2. Yeah. X plus 3, x minus 2 is, or no, x plus 2. Yeah, add to 5 and multiply to 6. Okay, that's going to equal 0, so x plus 3 equals 0. Or maybe x plus 2 equals 0. All right, now we are on to the last page. So w of x is going to equal x squared plus 2x. Find the solution. So w of x equals 2. All right, so x squared plus 2x is equal to 2. And I'm going to set this equal to 0. Taking 2 from both sides. And I'm going to try to factor, but this is not going to work. So I'm going to say, all right, x needs to equal negative b plus or minus the square root of b squared minus 4ac. Did I already do this one all over 2a? I'm not sure. I guess, yeah, I don't know. We solved a lot of quadratics in this video, so it's hard to remember what I have and haven't done. So this is going to be negative 2 over 2 is negative 1 plus or minus, all right, 4 plus 8 is 12. I do know that I have simplified the square root of 12 on this video already. That's 4 times 3, square root of 4, square root of 3. And we're dividing that by 2, so that's negative 1 plus or minus the square root of 3. Really feel like I've already gotten that one today, but... All right, now we'll find the solutions to w of x equals negative x squared minus 1. So x squared plus 2x equals negative x squared minus 1. Okay, so I'm going to add the x squared to both sides. Add the 1. I'm going to try to... I just think this one's very similar to one that I already did. Maybe I can check. Very similar. So 2x squared plus 2x plus 1 equals 0. This I need to use quadratic formula on, but I'm not scared. I've done it a bunch of times already. I can do it one more time. Negative b plus or minus the square root of b squared minus 4 times let's see. For the sake of clarity, I'm going to say 4ac all over 2a. And I've got x equals -2/4 plus or minus. If I take 4 and I subtract 8, that will be -4. And the square root of -4 is going to be the square root of 4 times the square root of -1, going to be 2i. So I'll say 2i divided by 4 is going to be 1 over 2i. You can call it I over 2 if you want to say a number. All right, what else do we got here? And then find the vertex on the graph of w of x. So x squared plus 2x. X is going to equal -b over 2a, which is 2 over 2 times 1, and that feels like -1. And then the y-coordinate is going to be the value of w with x equaling -1. It's going to be -1 squared plus 2 times -1. So 1 minus 2 is -1. My coordinates are -1 and -1. That's vertex. All right, now the last problem here. Side lengths of a triangle are x plus 5 squared, x plus 7, and x plus 10. If the perimeter of the triangle is 24, x squared plus 5, x plus 7, and 10. Perimeter is 24, so I'm going to add everything together. And that'll equal 24. Now this is looking like the type of quadratic that I'm going to need to set equal to 0 to solve. So collect the like terms. X squared, I only have one x. But then I've got 5 plus 7 is 12, and 10 is 22. So if I'm going to set this equal to 0, I need to subtract the 24 from both sides. And then I can factor. So two numbers that multiply to -2 while adding to +1 would be 2 and -1. And then I would get x equaling -2 or x equaling +1. Okay, but I do need to check these and make sure that I don't have anything like causing me to have a negative side length for a triangle, because then we would want to throw that solution out. But I'm not seeing it, like -2 plus 7 is a positive number. Anything squared plus 5 is going to be positive, provided that thing is a real number. So these are both possible values of x. And yeah, that's it. That's going to be all for these review problems. If you've done all of these, and you did all the quizzes and you felt good about them, you're going to do great on the test. Okay. And if you still feel like you need more, contact me or contact one of us, and we will get you the support you need. Okay, so thanks for watching. Hope this one helped.